Hey, how's it going, guys? So here we are back again for the Python Backnet Stacks Playground. So yeah, what do we got going on here? So basically, this is just a repository that we're making of how to build Python scripts that can read, write, scrape backnet networks, do a lot of cool things in building automation networks. Sometimes they call them OT networks for operations technology, which is the OT in the acronym IoT. I've been an OT technician for all my life, basically, as a building automation field person. So I used to commission HVAC systems for about 10 years in the field, programming, building automation, and I also did a little bit of retro commissioning for engineering consulting firms. They would have me recommission an old hospital or an old federal laboratory. That was also really fun. I really enjoyed that work experience. It was easy to go into an existing building and then just do recommission it, which is typically point by point in the HVAC control system. Is just to verify that all the dampers, sensors, all the I/O is still functional, as there's lots of broken valves, broken air dampers, variable frequency drives that don't work anymore. Lots of stuff can go wrong. It's kind of closely related to building automation service. So yeah, it was a great work experience. So back in the Python Backend Stacks Playground, when we combine, our technician field experience, you can couple that with a little bit of AI, how the world's going these days, and maybe even like a little bit of software engineering skill sets, where just a little bit can go a long ways. The models are getting really good at writing code, so if you can give the models like a little bit of direction on how you want the code to be written, it can do a lot of cool things. So yeah, this repository on GitHub, which I highly recommend learning Git. Git is a skill set you can put on your resume, build a portfolio. It's like an artist, basically. Every artist has something they could show off. So this is kind of my creativity in that realm. If you can say doing things with building automations, systems, and networking is creative. You can do anything these days with AI helping you build these tools. We even made a weather station that's like scrapes data from OpenWeatherMap API and puts basically discoverable backnet objects with web weather data, exposing that to the building automation system, which is actually somewhat of a useful application these days. To me, that was creative. Who else is doing that? Some other things, some people may have that built into the building automation systems. I found that, it's a little bit, the tool gets broken over time, so it's not very reliable. So how about just maintain your own tool? Some other things that I'm playing around with on the side is also scheduling buildings with, I'm going to show you this right now, through Gmail, through a Google Calendar, making a schedule. I even have my own test backnet, mimicking like how a building automation schedule would work. So that's a huge can of worms. There's actually like a whole framework, kind of like how the backnet protocol is a framework, web application frameworks. There's one of them is just for email calendar systems, which might be kind of like a cool thing to play around with. Maybe I should just put that as another vibe code app. Okay, so this has been kind of a work in progress. Like I've said before, Discord channel to chat with. We're kind of doing some AI assisted workflows. I still want to get into some of the more back into the computer science theory. We're still on day 27 of the AI generated coursework. Just getting into algorithms, and I kind of want to have AI fine tune that into fault detection algorithms. Like someday we can get into what fault detection is in HVAC systems and how it's like glorified alarming. So alarming in building automation systems is like if a pump fails or if a fan fails, if some critical equipment like a chiller cooling a blood bank or a hospital, if that fails in the middle of the night, when people are home sleeping, like that, we dial out and we notify the person on call. So fault detection is kind of like that, but it's more ran across historical data sets, but is kind of thought of in the same way. It's like very advanced way to look at logic and all these different variables and how they come together and be like, that's an alarm, that's a fault. So kind of think about it that way. Typically, fault detection is ran across historical data sets and to find a sensor that's flaky or a sensor that's been reading flatline values, or sometimes it's even can reveal like a broken valve or damper, causing simultaneous heating and cooling, and then a mechanical engineer can put energy calculation. If we fix that, what would be the return on investment? So that's fault detection. And then alarming is more dial out, this emergency has happened, but they're real similar, how we view something that happened. Okay, so like we have been going along building these primitive backpipes, back zero scripts. Then we played around with Voltron and OpenClaw, which I'm still playing around with. It's kind of fun. I recommend playing around with it too. Most people are playing around with the OpenClaw. To all the big OpenClaw YouTubers, they built all these tools of like combing the internet for Twitter feeds and doing all these things in the middle of the night. Comb all these different hacker news websites for the latest and greatest apps. So that's basically these AI agents are combing the internet all night long and building all these dashboards and Twitter feeds or whatever social media stuff, but no one is actually doing that. We could be combing the building all night long. We could be, how is the building automation system operating all night long? Make me a dashboard about that. So that's I have a lot of interest in exploring that through a different project called OpenFDD, which I want to integrate into this project in time. Maybe when we do the algorithms, which we might kind of fine tune towards fault detection algorithms. Let's get into that. So at the moment, we played around with Voltron a little bit, which is an IoT framework funded by the federal government in the U.S. specifically through Pacific Northwest National Labs. It's very challenging. It requires very, very advanced Linux and software engineering and IT to get it up and running. I think it's too hard for me, and I think it'd be really hard for a building automation team to utilize unless you have an IT person with advanced skill sets on staff. Then you might be able to hit the ground running with it. So then we started getting into vibe coding, front-end software engineering. So now HTML. So every building automation system these days is a web app, which we talked about. So let's make a building automation system. So we're kind of into here, vibe code app 10 of kind of just getting some very basic authentication for our web app, maybe do some alarms, schedules, trends, and a backend discovery. So which we're in right now, and then eventually we can get this into another phase of this. It's turning into the DIY BAS, do it yourself. So if you can eventually, I think that you'll be able to aim artificial intelligence at websites like this, comb this website, and just chat with it, make me a building automation system. And then if you know a little bit about Linux, a little bit about web apps, a little bit about Python, probably everything you can learn through here, I'm learning at the same time. do you need to pay $5,000 or $10,000 for a framework, a proprietary framework for building automation? My argument is no, but there are some, like if you're a startup, you kind of need these proprietary frameworks. They're expensive, but they also have a ton of support. So there's a support channel, there's tech support channels, there's distributors that sell this stuff, and people that can help you. So like if you're a startup in building automation, which I was there, I was a startup employee number one for Johnson Controls Facilities Explorer, Niagara branch at a local contractor where I lived. I needed definitely a ton of support at the time, which is not free, but you need that to get off the ground running. So like this should be very bad to do some kind of do-it-yourself building automation. But let's say you're a very advanced contractor where you have a very advanced team and you're very advanced workflows, and then you're already just kind of refining how can I maybe be more profitable or something like that, or I want to explore new avenues of making, I'm sick of using these frameworks or something like that. So maybe that would be like a good reason to start looking into other options such as this. So, okay, so let's get back into this. We've done this. We've made a very primitive app. We're kind of in here. So let's get into, where were we? So I'm just going to close out of this. Okay, so this is just a schematic that I made. So the test bench that I have a test bench with 3 Raspberry Pis. One of them is the fake air handling unit, the fake VAV box. There are also backpipes, 3 servers emulating the same kind of points that you would see in these devices in the field. Very similar to what you'd see in the real world. And then I just have like a little all linked together into the same Ethernet switch. So I'm on this Windows PC right here, which I'm recording this YouTube video on, 204.11. And then this one is just .13.14. I think this is wrong. It's not 113, it's 114. And then there's the BAS Pi that's running our web app for our Vibe Code App 9. So this one has Docker installed, which I think is like really cool thing to learn. So with a Docker-based system, there's a host operating system that's you can run Docker on Mac or Windows. I sometimes use it on this Windows machine, Docker desktop, to test out some things too. So what's really cool with Docker containers, these are all very thin Linux images themselves in here. So it's actually all these little containers. These are little Linux, completely little independent operating systems running in here, here, and here. And then it's all managed by the host operating systems. And then this will steal resources as needed from the host, basically for memory and hard drive space, all that type of thing. And there's typically there's port numbers that people use with these Docker containers. For example, like when I dial into the DIY backend server, which we demoed a few times, this is actually running, hopefully you can see this, it's TCP port 8080, and then it's also running UDP port for 47808. And then this is running TCP port 5050, so they talk to each other on ports. And then we can also dial into it remotely. So like when I dial into the BAS Pi, I could dial right into this Docker container on port 5050 through and gather its HTML through here. Same thing in here through the docs. And then we are also have a third Docker container running now that's called a reverse proxy. It's called Caddy. It's just a framework for web applications to do reverse proxies. So think of this as like kind of a gatekeeper. So this is like kind of a security tool. It can do authentication too, and then it can also do load balancing, a whole bunch of things. I don't even know. It does way more things than I think I even know, but it can also do load balancing where I think it can also do throttling. So like if this app was on the internet and people were hammering this website 1,000 times a minute, Caddy can throttle users. So basically it's like it'll act as the gatekeeper. So when we dial into this URL, we'll dial into Caddy, and then Caddy will forward us to these individual Docker containers, which I think is like what real web app software engineers do, is they use tools like this. So you're never actually talking directly to the Docker containers. You always go through reverse proxy. So yeah, hopefully that makes sense. So like we dial into here through TCP, and then the UDP port is opened up to talk to the backnet network through the DIY Docker container. I think the last time I checked this out, last time I checked this out, that I think Caddy is already proxying. So let's see if we can dial into this. I might even have to get a little refresher where we are. I can't even remember. I find out if I'm not like doing something every day. Okay, yeah, so Caddy is working already, because what Caddy did right here, if you can see that, I'm just dialing right into the URL of the BAS Pi, and then Caddy on port 80 technically, because when you dial into any website by default, it's port 80, and then if you would do TLS or encrypted, that's port 443, which we'll get into as well. Caddy can serve self-signed TLS certificates. So once we get into the next phase of the DIY BAS, we can do hardening and TLS and everything like that. So basically when I dialed in here, Caddy forwarded me right to port 5050. See if I can even hit that. So I think I would go like this. Actually, it would look like this. It's colon. Yeah, I could. Okay, so I can still get to the DIY backnet server. This is where we have to authorize just to use this APIs. So the DIY backnet server, I'm dialing into the HTML on here, which comes with the Fast API framework. And then this has all of our functions running behind the scene, the back end, where we could do everything basically that we did on this whole coursework built into a web app. And then I should be able to go dial into TCP 550. I'm just going to change that from 8080 to 550. And there we go. There's our same login. So this is me dialing right into the login, right into the Docker container here and here. Or Caddy at the moment can forward that to us. So when we get into the next phase of this project, we will use Caddy to exclusively not even allow us to hit these. That's more security things way down the road. I think we have a ton more to do, but just so that makes sense, hopefully this makes sense. And then at the moment, we're just using Flask because it's kind of like a very primitive, bare bones API framework. If we were building a website that would sit on the cloud and it would have 1,000 users at a time, thousands of people doing something, we probably wouldn't want to use Flask. But in the building automation world, the way that we're making this, there would be one person, the maintenance guy, dialing into this at a time. So Flask is probably a pretty good solution for that. And we don't need something super overkill. So that's why Flask is probably the easiest thing to use, because it's simple. And then for another thing is that building automation systems typically don't have a lot of users, and maybe one at a time. Unless you're on a really big network, there could be, 5, 6 perhaps at a time, but it's not like cloud-based platforms where there'd be thousands of users. So that's why our little application here is just kind of bare bones, nice and easy. Okay, so I'm just going to close out of that, and then I'm just going to dial into Caddy, which has forwarded us to Flask. And then, okay, so I have to actually refresher. Okay, so I can't even remember. So I'm just going to ask, let's see, so we're in here, vibe code app 8. I'm just going to drag things in to cursor. How to log in again? What is the username and passwords? So while that thinks, I think that there is okay, so there's a PowerShell script that I'll run that'll push all the code to the Pi, and then it'll rebootstrap itself. So hopefully that makes sense. So I'll run this PowerShell script, which will push all this code to the Pi, and then on the Pi, there's another bash script that'll run, and it'll kind of set itself up. So this is basically a config file. Okay, so maybe we're on the wrong one. I don't think we're on this one yet. Maybe I have this wrong. I think something's wrong here. Okay, so maybe we're on DIY. Maybe we're on vibe code app 10, not 9. Whoops. I meant 10. Let me just check that. Something seems wrong. I don't think we are up to vibe code app 10 yet. Oh yeah, sorry, I guess we were on the 10. Current, it even says current. Okay, sorry about that. So cursor is probably like, you idiot. Okay, so here we were. So we still have the PowerShell script and the env example. Okay, so what we get here is, here's our port numbers. So this is supposed to bootstrap the DIY backnet server and then just rename it as backnet server, which we'll test. We'll get into this as well, but this is a secret key that is used for making sure the app is secure, which is interesting. So we'll have to get into this. So AI made this, and then we'll just have to really test it to see if it's working. So right now we have 2 passwords, typically in building automation system, an integrator password and a maintenance. So I'm just going to abbreviate this as int and maint, and for testing, ASDF, integrator, maintenance. So what else is kind of cool about this web app framework, Flask? So we'll get into this probably in the next one a little bit more. It does have a login, Flask login, and then what I kind of requested to use is that we use cookies for authenticating. So there's this gets complicated, but just we'll get into this later. But to authenticate in web apps, you can use cookies, or you can use tokens, key bearer tokens. There's a whole bunch of different ways that you could do this, but I thought this might be kind of a cool way to do this, because we can probably build a pretty secure app, relatively easy, which we'll get into. And then keep this in mind is like Flask is just serving us one HTML file where all of the styles and the CSS, which is the coloring and all that stuff, and then all of the JavaScript, vanilla JavaScript, which means that it's not advanced. There can be, if a professional web app was doing this, they would probably use advanced JavaScript libraries called React, or there's a whole bunch of them actually, which we might do later on. Maybe we could rewrite this all in React. It's in someday. Okay, so just getting back out of this, this is what I wanted to modify, and then test, and then also we're saying like we want 30 days of data. Some of these I don't even know what they all mean. DIY being its latest values flush seconds. I think that's polling. And then I also put had to make an arg of log to file. So like when we have Raspberry Pis, which I have, you can burn out SD cards. So I'm trying to do like a little bit less logging to file, make it more SD friendly. Okay, so here we go. I'm just gonna say, I can't remember how to run this. How to run. So I think we just have to go to Python. Okay, Python. We're going to change directory into the 5 code app 10, I guess we're in. So here we are. This is in PowerShell here. So where are we at? We're here, and then hopefully that makes sense. We're still in, let me just go back into that schematic. Okay, so we're on Windows. Here's me on the Windows machine, and then I'm going to run a PowerShell script where then it'll, through secure copy protocol, SCP, it'll shoot over all of the files to the Raspberry Pi, and then it'll run that bootstrap bash script on the Raspberry Pi and set all this stuff up in Docker, and then we can just test it. Okay, so I think this looks good. I'm just going to copy this. Okay, cool. So we do have even more arguments. This is pretty cool. Let's see if this, ooh, it didn't work like that. All right, so let's just copy that back into the AI. I think what's neat is like these deploy to deploying this like with a PowerShell script. I would have never been able to make a PowerShell script. That AI is able to do all this, you know, for me, which I think is pretty cool. Okay, so maybe I wasn't in the right directory. So it's going to do a change directory. Weird. Okay, so I'm just going to try this one. See if we have a little better luck here. Okay, so that worked. I must have been in the wrong directory. Oh, I had to go into the DIY BAS directory. So right now it's shooting over the files to the Pi, and then it's basically going to re-bootstrap itself on the Pi, which we should be able to see all the logging from here as well. And then I want to test in that I can log in with int for the integrator and maint for maintenance, where the last time I asked it to hide some of the tabs, like if you were a systems integrator setting up building automation, that you can hide some of the tabs for backend discovering and kind of doing some of the local like setup of building automation systems, which the maintenance user doesn't need to see. It's pretty common. Okay, so this is just rebootstrapping on my old Raspberry Pi on the test bench, so hopefully this guy still has some life left in it. Before, we were kind of playing around with like that Raspberry Pi is too old to run cursor on, which kind of stinks. Alright, so it looks like it finished. Cool, done, no errors. Ooh, I do see some kind of error here. Oh, maybe that's normal. Error trace. Alright, so let's try logging into the Pi. Do a little refresh. Looks like we're good. Okay. Int. Right? So yeah, int. So I'm gonna try this out. Int and maintenance ASDF. Login. Ooh, okay, so it didn't like that. Int. System integrator ability operate unenforced servers. So why didn't it like that? Let's try maint. Great. Login fails. On those, how to troubleshoot. So I'm just gonna feed it in. Oh yeah, look at this. Some kind of error happened. So I'll just feed it in from here down. Now the thing is, I do have Docker Desktop here. Multiple issues to address. Alright, so now it's rewriting. It's kind of tempting. I might just fire up Docker Desktop. Just in case we have to fire this up locally. It takes a little while for Docker Desktop to fire up on my Windows machine. Oop, there it goes. So this is kind of a cool tool as well. For Windows, you can use Docker Desktop. It's free. And you can spin up Linux containers. I was playing around with the OpenClaw on this as well. Whoops, get out of here. Delete. Alright, so let's see what it's doing here. So we got Docker Desktop open. Wait here, there's a critical issue. I thought this was a little further ahead. Sorry about this, guys, but this is kind of the fun stuff. So while AI kind of writes your software, you could go get a coffee, walk around the block. Kind of the world we live in. But it is kind of nice to know like what it's doing. I am like kind of half familiar with Flask. I've been playing around with it for a while. So maybe this is kind of like a nice, kind of just maybe take a little stab at like what it's doing. Okay, wow. So like this is actually creating something to do with that's SQL. We will have to look and see exactly what it's doing, but I think it might be creating like a SQLite database. We'll have to explore this later. This is an algorithms Pi, because we need to know a little bit about how to alarm. how to share outside air temperature data. That looks kind of funny. Trying to do something with web weather. It might be kind of cool if we built a tool. So one of our older Vibe Code apps was to scrape data from Open Weather Map. Maybe we could incorporate that into here as well. Okay, what you should do now in the Pi, I'm just going to shoot all the files over and rebootstrap it. I'm going to tell it that. Shoot over the files and rebootstrap. Won't that work? Kind of easy button for me. Yes, it's extremely convenient. Yeah, of course, it's just warning like it will replace, it'll delete the data, which is fine. Okay, so now we're rebootstrapping on the Pi. Maybe we can just ask for like, what kind of database saves the data for trends? I haven't had time to even see. Okay, so it built SQLite. So it's a single file embedded SQLite database, not a separate server like Postgres. So these are more advanced databases, but SQLite is actually really easy for development purposes. Maybe in time, we could even vibe code this into using Postgres. I know is a very popular one, MySQL. Postgres has time series support as well. But maybe for the time being, I'm sure SQLite is good enough to kind of get concept idea going. Oh no, it did this. So AI automatically changed the username and passwords back, which is really annoying. I just wanted it kind of simple, but I suppose we can just copy paste. Okay, so done. Alright, so let's try again. Integrator. Refresh. Okay, so we got the integrator. Change me now, 1, 2, 3. Invalid credentials still. Okay, so still failing invalid credentials. I'm just gonna send all this back over. Well, this is kind of lame. Sorry, guys. Huge video and we haven't even got anywhere. I'm gonna copy paste all that and ask it to, I have Docker desktop fired up on this machine. Please iterate until the app is stable and test login locally with PowerShell curl to the UI. Alright, so I think I might stop this one here and I'll kind of play around with it and then see where it's failing, but this is the fun of all this good stuff. Maybe if it's not too bad, I'll just give it like 2 more seconds to see if it can fix itself. But I kind of doubt it will. Well, yeah, maybe I'll just leave it here and then I will try and we'll be creating. I'll create a video. Try to do a video every day just till this is done. But I want to get to the point where we can validate that we can backend discover a network. We can pull in all the points. We can set up trending. We can set up alarming. And then I also want to do email SMTP. So like every building automation system has a way to dial out, notify the maintenance staff if the pump has failed or if a point is, or something failed critically. So I think that's something, just for my own learning purposes, I've never done that before in Python. It might be kind of fun to play around with. And we can kind of validate that it works the way we should. So this is kind of the way, so it's rewriting everything. It keeps iterating until it kind of gets it right. But I think I'll stop it here, and I'll see you tomorrow, and I'll show you what I had to get it up and running. Talk to you later, guys.